In this video, we will be discussing important information on Martin lighting smoke technology. This training will cover the technology behind Martin GEM smoke machines, discuss calibration, and provide some brief maintenance guidelines. This information will help familiarize you with the GEM product and maintenance for the machines to keep them operational and reduce downtime when servicing. How does a smoke machine and a haze machine differ? The smoke fluid is transported from a container in the machine to an oscillating piston pump, then passes through the pump into a heat exchanger where the fluid is vaporized and exits from the output nozzle as smoke. The haze machine uses the same principles to create haze, except the output exits into a metal chamber where there is a fan that creates a fast-moving airstream which disperses the smoke output and creates the haze. The effects of each machine also produce different results. As the image to the right shows, smoke is thick, visible, and the visual effect is obscuring, where the haze is thin, invisible, unobscuring, and it enhances the visual effect. How does a smoke machine actually work? More details on specific components will follow in this training later, but here's a brief description of the technology behind the process. You power on the system. The system then checks the thermocouple. The PCB heats up the element once it receives a confirmation from the thermocouple that the heater is not yet hot. Next, the pump is energized. Lastly, fluid will flow through the heater to create smoke. There are many different types of heat exchangers, but the units used by Martin are bare aluminum block and cartridge heaters. The cartridge heater is used in a Martin compact hazer. It heats up to the full temperature in a very fast 90 seconds. However, it has a very sensitive heater block. Therefore, it is prone to obstructions if the wrong fluid is used or if the unit isn't maintained and serviced correctly. The heat exchanger is made of a heating element and coiled copper and steel tubing between 3 and 6 meters long. Most people don't realize how incredibly long the tubing is inside the heater block. The long length of the tubing is the reason why it is nearly impossible to clear an obstruction once the heater is blocked. A J-type thermocouple fitted to the heat exchanger monitors and controls the temperature. These are physically staked inside the aluminum block. The blocks are created and cast in 2 large ovens at the factory where the quality can be controlled. Sometimes heater elements have problems. Figures 13 and 14 reference a short circuit and an open circuit respectively. A short circuit is usually caused by a user error. When a faulty heater element has to be replaced and a new part is received, the elements are straight and requires the technician to bend them, then fit them inside the unit. If not correctly done, this process presents a high risk of creating a short circuit. It is suggested to use the ring ends of 2 spanners and push them together to create a smooth curve. An open circuit happens over time due to the heater repeatedly getting hot and cold, causing the material to constantly expand and shrink, where it eventually creates a break in the circuit. When opening a smoke machine, the resistance can be measured at the heater elements to determine if the unit is operating correctly. To comply with EU and global regulations, 2 thermo switches are necessary on the heat exchanger. One is usually mounted on top of the block and the other is on the side. The thermal switch is used to prevent overheating in a heat block that can lead to component damage in surroundings. The switch on the side has auto reset, and the switch on the top must be manually reset. If the top switch trips when the unit overheats, it is imperative the switch is not bypassed, as this can cause the element to get so hot it could melt. If it is mounted high above, hot melted material can drop and burn severely if it comes in contact with skin. The Martin GEM smoke and haze machines sometimes use fluid pumps and occasionally use air pumps. It is important to be able to identify which fluid pump is used or needed because there is a small 12-volt version as well as a larger standard 120 and 240-volt versions. Hazers will use the small pump since it needs to pull a small amount of fluid, and the smoke machines use the standard. The air pump, used in hazers, is designed to smooth out the output as it is pushed out of the unit. The low fluid shutoff system was phased out by Martin over time and could be still seen in the discontinued GEM Glaciator X-Stream. This was the only exception, where all others were fitted with a digital sensing system. The system PCB looks for the changes in temperature of the heater. If it doesn't detect changes in the heater, it assumes there is no fluid being passed through to cool down the heater block. Therefore, it will report the fluid out. The GEM Ready 365 is a discontinued product. However, the layout is fairly standard. The unit in the image has a power and pump board, a DMX board, a display board, and a filter board. With a standard machine, there's usually a pump, a heater, and PCB. As long as there is an understanding of identifying and testing these three components, then you'll be able to repair a smoke machine and most of the other parts won't matter. This slide is primarily to show the wiring schematic of a 240-volt Martin Rush Club smoke dual base unit for informational purposes only. Shown in this image is the haze head to the left, the fog head to the right, and the base or pump unit centered. The fluid matrix has changed from this older version that supported some discontinued and older units to this latest version that supports current units. The updated version of the fluid matrix can be obtained at the Martin website. It is important to note that you cannot put any fluid through any machine, particularly with the haze machines, which are very sensitive to fluids. If a standard smoke machine fluid is used in a hazer, the heater can become blocked almost instantly because the fluid is much thicker. On the other hand, if haze fluid is used in a smoke machine, it will spray out hot fluid as opposed to haze or smoke because the fluid is so thin it doesn't have time to build resistance in the heater. Some machines are better at coping with a change in fluid, but it is recommended that the fluid matrix be followed. The older matrix does point out that recalibration may be required because there are some units that may be required to output a different effect. Although not specified, this may be the same regarding the latest matrix. For example, in order for smoke to disappear quicker, faster dissipating fluids are used that burn off at a higher temperature. In order for this to occur, the heater has to be recalibrated. Recalibration should only be done by a certified technician. The warranty is voided if any non-Martin fluid is used in any of the Martin machines. Martin fluid should always be used because the variation in different non-approved fluid mixtures makes using them quite dangerous and can cause spraying of hot fluids from the machines. The calibration tool mimics a heater, so a millivolt reading can be sent back to the PCB, emulating the temperature rise of a heater. The calibration can be used for two purposes. The first is the calibration as it was designed for. The second is to use it as a mock heater. If you want to test for the pump's correct operation, slave the calibration box over the thermocouples and send the millivolt reading so the machine goes ready. You can then fire the machine and verify the pump is working correctly. Regular maintenance should be performed on smoke machines. Unfortunately, they tend to get forgotten and left in locations where they can collect dust or in areas where liquid and debris has spilled or collected on them. If the machine stops working, so do the effects with the lighting. Fluid should not be left to sit inside a machine because it can shut down the PCB and it can actually corrode the paint, causing rust to form. If there's a partial clog in the unit, Martin Pro Clean Supreme can be used to possibly dislodge the blockage and provide good output. This won't suffice for a complete blockage. As mentioned in earlier slides, if the tubing is blocked, it will be necessary to replace the heater. When replacing heaters, there are two different options. One is the bare heater, and the other is a complete assembly. The complete assembly comes with everything, including the steel casework and the insulation that surrounds the element in the heater. However, the price is considerably more for the complete assembly than the bare aluminum with the brass work, but relatively straightforward to replace. Using Loctite 542 thread sealant on the replacement of the pump or the heat exchange is very important and should be considered mandatory. Loctite should be used on the threads between the brass fitting and the plastic pump. If this is not done, over time, deterioration of the seal will occur and cause the fluid to leak, which will lead to lower output since there will be less fluid going through the heater. Also, fluid will have leaked inside the unit. The most important task to perform with maintenance is to recalibrate when replacing a PCB pump or heat exchange. Every heater, pump, and PCB will have a slight difference in variation of output, temperature, and housing, so it is important that calibration is done every time one of these parts is affected. Processes for calibrating heaters with a digital PCB, calibrating analog heaters, and updating firmware can be viewed in other Martin videos for the GEM products. This concludes this service training. Thanks for watching, and we'll see you in the next one.